Good morning, children. Enjoy the heavy rains, eat well, sleep well, and enjoy the days ahead. Along with that, we can learn some maths as well. The other day, you learned about properties of whole numbers. You learned about closure property, how addition and multiplication are closed under whole numbers, whereas subtraction and division is not. Okay. Now, today we are going to learn about division by 0. How do we divide by 0? Before dividing by 0, well, let us see how do we divide any other number. Now, division by a number means subtracting that number repeatedly. For example, let us find 8 divided by 2. Now, how are we going to do this 8 divided by 2? We are going to subtract continuously 2 from 8. Let us see here if we do 8 minus 2. What will be the answer, children? 8 minus 2 will be 6. So, let us start. So, 8 minus 2 is 6. Then 6 minus 2 is 4. 4 minus 2 is 2. Let us see how many times we are repeatedly subtracting. Okay. 8 minus 2, that is 6. 6 minus 2, that is 4. 4 minus 2, that is 2. And 2 minus 2, you get 0. So, how many times we have subtracted 2? One time, second time, third time, fourth time. So, 8 divided by 2 equal to 4. Until you get 0, you divide. This is continuous subtraction. That is division. Continuous subtraction is division. So, you get 8 divided by 2 equal to 4. Isn't it? Now, if we are doing division by 0. Okay, let us now try 2 divided by 0. Now, if I try 2 divided by 0, I have to continuously subtract, isn't it? 2 minus 0. 2. Again, I have to subtract 0. Again, I will get 2. Again, I have to subtract 0. At any point of time, will I get 0 as the remainder, children? No. We are not going to get 0 as answer. It will keep coming as 2. Understood? So, division by 0, there is no end to it. Therefore, we say that division of a whole number by 0 is not defined. Okay? You have to learn this word, not defined. You don't say that it is not possible. The word used in maths is it is not defined. Division by 0 is not defined. Okay? Now, we are going to learn about some more properties of whole numbers. The last day we covered closure property. Now, children, there are certain things that we do in a home, isn't it? Now, mother will cook the food first, or you will have the food first for your breakfast. Mother has to cook, only then you can have the food, right? So, the same way, there are some ordering. But one mother is bringing and keeping puttu for you, puttu. Then there is curry is there. Then there is banana. Then there is egg. Now, it doesn't matter that if you eat egg first, or you eat your puttu first, or you eat you drink the tea first. That doesn't matter, isn't it? So, in life, some cases it has got an order. In other cases, there is no order. Okay, you will understand what I am speaking about clearly. I have uploaded a video. Watching that, you will understand this class better. Okay. So, this is what I am saying. Something has to be done in order. Some things, in any order you do, it doesn't make a difference. So, we are going to find out about those things. Let us see. First one is commutativity of addition. Now, commuting from one place to another. Now, suppose there are two places. One place is A, and you are going from here to A to B. So, we say that you are moving from A to B, or you are commuting from A to B. Commute by bus, commute by walk. Okay, commute is the word. So, commute, you are going from A to B, and you are coming back from B to A. Anyway, you are traveling the same. Now, commutativity of addition, it comes this way. See, children, if you take any two numbers, for example, if you take 5 plus 3, that is equal to 8. Now, if you take 3 plus 5, that is also equal to 8, isn't it? 0 plus 2 equal to 2. 2 plus 0 equal to 2. That is, any way you do it, the answer is going to be same. Whether you take this one first or the other one first, anyway, whichever way you, the order, whatever be the order, the answer is not going to change. That is commutativity of addition. So what are they saying? You can add two whole numbers in any order. We can add two whole numbers in any order. We say that addition is commutative for whole numbers. So commutative means any order. You can take it in any order. Okay. So this property is also known as commutativity for addition. Now let us see commutativity for multiplication. Similar way, children, commutativity of multiplication. If I take 2 into 5, what is the answer? 2 into 5? 2 into 5 is equal to 10. If I take 5 into 2, 5 into 2 is also equal to 10. If I take 6 into 4, that is 24. If I am taking 4 first, instead of 6 I am taking 4 first. 4 into 6, that is also equal to 24. So can you see, children, there are no changes. Whether I take 5 first or 2 first, answer is going to be 10. Whether I take 6 first or 4 first, whichever be the order, the answer is going to be 24. So what can you say about multiplication? Multiplication is also commutative. You can multiply two whole numbers in any order. We say multiplication is commutative for whole numbers. Is it clear? So addition and multiplication are commutative for whole numbers. Now, what about subtraction and division? When we take subtraction, let me take the example of 2 minus 7. If I take 7 minus 2, you have 7 toffees and you are giving away 2 toffees to your brother. You have 7 toffees and you are giving away 2 toffees to your brother. Then you get 5. Isn't it? You got only 2 toffees and you have to give 7 toffees to your brother. Is that possible? You got only 2 toffees with you, but you have to give 7 toffees to your brother. Is that possible? No, it is not possible. So what about subtraction? Any way you write, is the answer going to be same? No. So subtraction is not commutative. So what can we say? Subtraction is not commutative. Subtraction is not commutative. Okay. Now what about division? Division, if we take 24 divided by 6. 24 divided by 6. What is the answer? 4 6 are 24. So 24 divided by 6 will be 4. What will be 6 divided by 24? 24 divided by 6 means you got 24 chocolates. You got 24 chocolates. You are giving these chocolates equally to your 6 friends. You are giving chocolate equally to your 6 friends. Then what is the number you are getting? 4. Each friend will be getting 4 whole chocolates. Okay. Now you got only 6 chocolates. And you have to give it to your 24 friends. Is that possible? You will have to break it. Can you give it as whole? No. You will have to break it. So you get it as a fraction. 6 by 24. Or you can simplify. Later you will learn the 6 by 24. So the answer is not the same. Isn't it? 24 chocolates, if you are giving to your 6 friends, each friend will get 4 chocolate. But 6 chocolates, if you are giving to 24 friends, they won't get even 1 chocolate. You will have to break the chocolate into small pieces and then give. Isn't it? So, division is also not commutative. Understood? Division is also not commutative. So, what you have understood? Any way you do multiplication, any way you do addition, answer is not going to change. But you cannot do subtraction and division in the same way. Is it understood? You cannot do subtraction and addition in the division in the same way. Okay, it cannot. It has a specific order. You have to maintain that order. Association. That is, if 3 people are there. 3 people are there. Let me take 3 people. A, B and C. All the 3 are friends, you think. Okay. So, what happens? A plus B were sitting in the park. A plus B were sitting and talking in the park. Then C comes later. A and B are together already. Then C comes later. Now what happens at the end? What is the result? At the end, what is the result? A, B and C are together. Understood? Or A and C, B were dancing and then C also comes and joins them. Now at the end, A, B and C are dancing together. Now if A and B were sitting together and in the second case, B and C were sitting together first in the park. B and C were sitting together in the park and A comes and joins later. Now how many are sitting there in the park together? A, B and C are sitting together. Okay? Or first B and C were dancing. They were there in the party. Then A also comes and joins. Then what is the result? All the three of them are dancing together. This is association. It is just for clarifying. When I explain, you will know. Okay? So what is the answer? Let us see. Let us see the number 2 plus 3 plus 4. What I have explained, you will understand now. This is my A and B. 2 and 3 have come together first. So we'll add. It is in the bracket. We'll add that first. So we'll get 2 plus 3, 5. Then we are adding 4. Can you see? 5 and 4. 5 plus 4. Answer is 9. 5 plus 4 is equal to 9. Now 3 and 4 were sitting together. 2 came first. So 3 and 4 is in the bracket. We'll be doing 3 and 4 first. 3 plus 4, 7. So 2 plus 7 equal to 9. Both the ways we are getting the same answer. Can you see? This is what we call as associativity of addition. That is, whichever way you associate, if 2 and 3 associates together first or 3 and 4 associates together first, whoever joins first, that doesn't matter. Whomever you add first, that doesn't matter. The answer you get will be same. Okay. Now, when you go for, that is, let us see the number. Add the numbers 234, 197 and 103. Let us see. I am going to add the numbers. 234 plus 197 plus 103. Now, I'll add these two numbers first. I am adding these two numbers first. You start from the left side, isn't it? So, I have 234 plus 197. Can you give me the answer? 4 plus 7, it will be 11. Carry over 1. 1 plus 3, 4. 4 plus 9, 12. Sorry, 4 plus 9, 13. For 13, 3 will be there. Carry over 1. 1 plus 2, 3. 3 plus 1, 4. 431. You get the total as 431. Now there is some more to add. So we'll get here as equal to 431 plus 103. Okay. So now we'll add 431 plus 103. What will be the answer? 3 plus 1, 4. 3. 5. 534. Answer we are getting it as 534. Now if I am adding 234 plus 197 plus 103. I am adding these two numbers together. Now which one will I add first? I have to add in the bracket first. So I have 103 plus 197. So when I add, what will I get? 3 plus 7, 10. Carry over 1. 1 plus 9, 10. Carry over 1. 1 plus 1, 2. 2 plus 1, 3. So what do I get here? 234 plus 300. What is the answer, children? 234 plus 300. 2 plus 3, 5. 534. Are you getting the same answer? Yes. We are getting the same answer. But which way was easier for you? Which way was easier for you? The second one. 234, 197 plus 103 was easier. Isn't it? Yes. Do you see, children? When we are adding 197 and 103. 197 and 103 when we are adding, that becomes easier for us. Because 197 plus 103 is 300. Now this is what we are going to look into. This is why we are learning commutativity and associativity. That is, in this question, you can either add 234 and 197 together first, or you can add 197 and 103 first. Anyway you add, answer is going to be same. Now which one will you choose? If you choose that way, is the answer going to change? This is what is meant by commutativity and associativity. To make our addition and multiplication easier, can we do it in an easier way? That is why you are learning this commutativity, associativity, etc. Okay. Now let us look into the next slide. For example, before going there, let me tell you. In the same case, we have seen that 2 plus 8, 3 plus 7, 4 plus 6, 5 plus 5, all these add up to 10. These are the things that add up to 10. Now if I give a number as 35 plus 43 plus 27, I am asking you to add. Will you add 35 and 43 first, or will you add 43 and 27 first? How we decide is, we decide the digits in the unit place. You decide. This is 5. 5 plus 3. 5 plus 3 is 8. So, 5 plus 3 is 8. We will see where we are getting 10. Can you see? 3 plus 7 is 10. 3 and 7 if you add, you will get 10. So, for getting 10, we will immediately put these two in brackets. This we will do first. Then it will be easier for us. Okay. Let us see. 43 plus 27, what is the answer? 43 plus 27. 3 plus 7, 10. Carry over 1. 1 plus 4, 5. 5 plus 2, 7. So you get here, this is equal to 35 plus 70. Now when you add 5 plus 0, 5. 3 plus 7, 10. 105. If you are doing it other way, 35 plus 43 plus 27. If you are doing it the other way, you see children, 5 plus 3 you will get 8. 3 plus 4, 7 plus 27. Then addition again it is 2 digit. You have to add 8 plus 7, 15. Then 1 plus 7, 8. 8 plus 2. Okay. So which one is easier? Whenever you get this tens, the addition, multiplication and all becomes easier. So this is what we are looking into today. Okay. Is it clear? So let us find 7 plus 18 plus 13. 7 plus 18 plus 13. How will you do? 7 and 18 or 7 and 13? We'll take 7 and 13 together. 7 and 13 will be together. How will we bring 7 and 13 together? Here 7 is there, but 18 is there in between. Isn't it? 7 plus 8 I can put it together as bracket, or I can put together 18 plus 13 as bracket. Now how will I bring 7 and 13 together? If I add 7 and 13, the problem is going to be easier for me. Now for this what I'll do is, I'll put 7 plus, I'll exchange these two. Okay, I'll write it as 13 plus 18. Now is this okay children? We have learned 5 plus 4 is equal to 4 plus 5. Isn't it? What is this? You can write this way or you can write that way. This is commutativity. We have learned just now, isn't it? This is commutativity. So we are going to use it over here. So in this case what I did, I first changed these two. So what I got? I got commutativity of, what did I do here? I did commutativity of addition. Is it clear children? Commutativity of addition. This is what I have done here. Okay, 13 and 18 I have exchanged. So what do I get? Now what will I do? I'll put 7 and 13 together. So in the next step I am putting 7 and 13 together plus 18. Now putting together is associativity. Here I have associated 7 and 13 together. Associativity. Associativity of addition. This is addition that I am doing. So associativity of addition. When you write children, you will have to write it this way only. Commutativity of addition, associativity of addition. Then what do you get? 7 plus 13 is 20. 20 plus 18, that is equal to 20 plus 18, 38. Now children, you can do it this way also. That is, if I am giving you 7 plus 18 plus 13, you can bring these two also together. That is, you can write it as 18 plus 7 plus 13. Then also this is commutativity. You are taking 7 and 18 together. You are taking 18 plus 7. This is again commutativity. And you are getting here 7 plus 13 together. You will get associativity. Any way you can do. The thing is, we bring those numbers together which are easier, which makes our calculation easier. Okay, this is what you have to learn. Now let us look at the second question here. That is 16 plus 12 plus 4. We have 16 plus 12 plus 4. In the first case, I exchanged 18 and 13. Here I will exchange 16 and 12. Okay, why? Because 6 plus 4 is 10. 6 plus 4 is 10. So I am going to bring 6 and 4 together. So what I am going to do is, this is equal to, I will write here, this is equal to 12 plus 16 plus 4. What did I do here? Why did I change? Yes, I used the property of commutativity of addition. Why did I use commutativity of addition? Because any way I add, the answer is not going to change. If it is 16 plus 12 or 12 plus 16, answer is going to be same. Now in the second sentence, what I am going to do, second 16 plus 4. I am going to do 16 and 4 together first. I am going to associate 16 and 4. Only for bringing 16 and 4 together, I have done this commutativity. So this is associativity of addition. Are you following, children? Yes. So what do you get? This is equal to 12 plus 20. That is equal to 12 plus 20 is 32. Addition becomes easier for you. Okay. I hope you have understood this. We'll move on to associativity of multiplication. Let us see which one is easier. 6 into 5 into 3 or 6 into 5 into 3. Let us take the first one. That is, I am taking 6 into 5 into 3. 6 into 5 if I take first, I will get it as equal to 30 into 3. Then we have only 3 into 3. 3 into 3 is 9 and then we have to put one 0. Answer is 90. Now if I take 6 into 5 into 3. If I do 5 into 3 first, then I get 6 into 5 into 3 is 15. Then you have to, if you know the multiplication table of 15, very well and good. Otherwise, you will have to multiply and find out to get the answer as 90. Isn't it? So which one is easier? This is easier. 6 into 5 is easier. Because 6 into 5 we are getting 30, a multiple of 10. Okay. Similar way, can you say 9 into 4 into 25 or 9 into 4 into 25? First one, if you take 9 into 4 into 25. 9 into 4 is equal to 36 into 25. Can you write the answer in one sentence? No. Let us see the other one. Okay, 9 into 4 into 25. Children, you know, 5 fours are 20. 5 fours are 20. 4 into 25 is 100. Okay, 4 into 25 is 100. So what is the answer? 9 into 100, 900. Now if you multiply and see here, this case 36 into 25. 5 6 are 30, carry over 3. 5 3s are 15, 15 plus 3, 18. 2 6 are 8, 2 6 are 12, carry over 1. 2 3s are 6, 6 plus 1, 7. Now what do you get? 0, 8 plus 2, 10, carry over 1, 1 plus 1, 2, 2 plus 7, 9, 900. Here also you got the answer as 900. See, here you have a big number to multiply, 36 into 25. But here it is 9 into 100 only. Can you see? So this is the benefit of learning commutativity and associativity. That is, you can join the numbers together easily and then find out which multiplication will be easier for you to calculate. Now just like I told you, 9 plus 1 is 10, then 7 plus 3 is 10. We'll see how we'll get. 2 into 5 is 10. Then what will be 20 into 5? 20 into 5 will be 100. So if you know 2 into 5 is 10, then you know 20 into 5 is 100, or 2 into 50 is 100. isn't it? 2 into 5 is 10, one more 0. 2 into 5 is 10, one more 0. If I do 20 into 50, then you will get 2 into 5, 10, and then 2 zeros, 1 0 here and 1 0 here. So that will be 1000. Understood, children? So 2 into 5 equal to 10. So you know 2 into 5 will be a multiple of, will be giving 10. So whatever numbers you add to this, how many ever zeros you add to it, that is going to be a multiple of 10. Similarly, you know 5 into 4 is equal to 20. So what will be 50 into 4? 50 into 4 will be 200. Understood? Now there are certain things that you should know. 4 into 25. 4 into 25 is 100, children. Okay. If 4 into 25 is 100, then 40 into 250. What will be 40 into 250? 40 into 250 will be 4 into 25 is 100, and then how many zeros more? 2 zeros. So you'll put 2 more zeros. Understood? So you get the answer as 10,000. So the answers you should be remembering is all the multiples where you get 20, 30, etc. You should be knowing all those multiples. That you'll be knowing. Again, the extra things that you should be knowing is 4 into 25 is equal to 100. This you will have to write in your notebook. Now itself, you take a paper. When you're watching this itself, you take a paper, a book nearby, and put it down in your notebook. Put it down in that paper. Later, when the notes are given to you, from the notes, after writing the notes, somewhere on the right hand side in the working column or somewhere, you can write and keep these numbers. Okay. 4 into 25 is equal to 100. 8 into 125 is equal to 100. Sorry, 1000. 8 into 125 is equal to 1000. Then you have 625 into 16. That is double of this, 25. 25 double. 25 into 25 is 625. 4 into 4 is 16. So 16 into 625. That will be equal to how much? This is 100. So its double will be 10,000. Understood? These numbers you should remember and keep. Only these numbers extra will be coming for you. These numbers when you see, you should know. The questions will come like that. Okay. When these numbers comes, you should know that it is 100, 1000, 10,000, etc. Let us look at these numbers. Can you see here? It is given 25 into 8358 into 4. Now how are we going to do this? 25 into 8358 into 4. We know that if we bring these two numbers together, 25 into 4, 4 into 25 is 100. I've just taught you now. How will you bring these two numbers together? These two are far away. So we have to change it and write. How will we change it and write? We will exchange these two numbers. How will we write? A into B is equal to B into A, isn't it? 5 into 4 is equal to 4 into 5. So what we get? 25 into 8358 is equal to 8358 into 25. What do we call this? This is, what is the property? Commutativity of, what are we doing here? This is commutativity. Commutativity of multiplication. Commutativity of multiplication. So we are changing here. We get it as 8358 into 25 into 4. We have done here commutativity. This here we are doing commutativity of multiplication. Now what we get? We in the next sentence we'll make it, put it in the bracket. Whichever one we are planning to do first, we'll put it in bracket. So when we put it in bracket, we get this is equal to 8358 into 25 into 4 is 100. And the answer is 835800. Can you see, children? Such a big number was given for you to multiply. See, you have done it mentally only. Mental calculation. You have got the answer without putting that long columns of multiplication, 25 into 8358, then into 4. Without all those, you have found the answer so easily. Okay. This is the use of associativity and commutativity. The second question, children. 625 into 3759 into 8. Now how we are going to do that? Okay, let me see here. 625, what you do is, you have learned that 625 into 16 is 1000, isn't it? The question is given as 625 into 3759 into 8. Now we know 625 into 16 is equal to 10,000, isn't it? Now can we get 625 is here, can we make it into 16 anyway? Or don't go for that. 625 into 16 we know it is 10,000. So 625 into 16 means it is 625 into 8 into 2. 16 is 8 into 2, isn't it? 8 into 2 is equal to 10,000. Therefore, what will be 625 into 8? Are you getting me? 625 into 8 into 2 is equal to 10,000. Why? Because 8 into 2 is 16. So, what will be 625 into 8? 625 into 8 into 2 means double. So, half of 10,000. Half of 10,000 it will be 5,000. So, 625 into 8 will be 5,000. So, we have to bring 625 and 8 together. So, how will we do this? 625 into 3759 into 8 can be taken as 625 into 8 into 3759. What are we doing? We are exchanging these two. So, here we are using commutativity of multiplication. Then we get here 625 into 8 is 5,000. We got the answer, it is 5,000 into 3759. Now we have to multiply 3759 only with 5. So if you multiply 3759 by 5, you get 5 nines are 45. Carry over 4. 5 5s are 25 plus 4 29. Carry over 2. 7 5s are 35 plus 2 37. Carry over 3. 5 3s are 15 plus 3 18. So you get 18 7 9 5 18,795. Now how many zeros are there? There are 3 zeros here. 5,000. The 3 zeros are there. We'll just put the 3 zeros there. So we got the answer. I hope you have understood. Now I have given another video for you to understand it clearly. And then there is some homework also given, notes also given. Okay. Watch it. Enjoy your day. Okay children. Bye-bye.